Hello students, you are welcome to the next teaching session that is all about similarity. So before doing similarity, we need to have some kind of information about what is congruency. So congruency is all about the things which are just replicate, or you can say they are just duplicate of each other. In what sense? So let us start with that first of all, and then we will come to know many things about similarity in this session. So let me move on to the very first slide. So how you can say that the two things are congruent? Suppose you have got two triangles. How you can say that the two triangles are congruent? So as to prove that two triangles are congruent, they need to have exactly same, what we call, they should have exactly same what? As you have already done this, so you should be very much aware that for two things to be congruent, they need to have exactly same size as well as shape. So what about similarity? So how we can say that two things are similar? So for similarity, you need to have the two things which are being just compared should be exactly same, should have the same shape, but may or may not have same size. May or may not have same size. So why I'm saying so that it is just because if we have two things which are just replica of each other, still they are similar. And the similarity proportionate between these two will be 1:1 only. But if the two things are in some other ratio other than 1:1, then they will not be congruent, but they will be similar. So from here, what you can deduce out of it is that, can you make out, any one of you? All congruent things are similar, but vice versa is not true. We have already discussed why they are not going to be similar. That is just as if the ratio is not 1:1, then they are not going to be similar. Okay, let's move on to the next slide. Okay, so for that, okay, let me. So they're having the same shape and size, even if they are flipped around any, you can say 360-degree, they should have the same shape and size. But in case they are just similar, in that case, they should have the same shape, but flipping is still allowed. Okay, let's go on to the next slide. Oh, I jumped up. So can you make out what will be the length of this perpendicular? So what will be the length of this side? Can you make out? What will be the length of this side? As it said that the things should be proportional or the sides should be proportional. So in this case, let me mark this as A, B, C, and this as P, Q, R. So in this case, AB is similar to PQ, or you can say they should have the same ratio. That should be equivalent to BC ratio QR. So in this case, if you look at this, we are given that this is 5 and we don't know the value of the PQ. So let me mark that as X. and should be equivalent to what? 8 upon 12. So using this, we can find out the value of x. So if you look at this, this will be 2 here, this will be 3. So this will make it x equivalent to 15 upon 2, or you can say it is 7.5 units. So this is how you can find out the length of any side if the two things are similar. They need to be similar, only then you can use this. Okay, let's move on to the next slide. Okay, let me just get rid of this. Okay. So now we are having again same kind of exercise with us. So any one of you can answer? Okay. So if you look at this first figure, 10 should be proportional to the question mark, or you can say x, and it should be equivalent to 15 upon 18. So now you can use your method to find out the value of x. So let's move on to the next figure. It has got 24, 15, and on the other triangle you have question mark and 20. So in this case, what you need to do is just find the ratio of 24 and 15, and that will be equivalent to the ratio of x to 20. So I just replaced question mark with x. So in the next one, they just flipped it. So we need to be very careful about this question. So let me mark this as A, B, C first of all. And so it should be 24. And this is your P should be here. It should be here and it should be here. So it should be AC upon PR equivalent to what? AC upon PR should be equivalent to what? BC upon Q. So now you just need to put on the values and find out the answer. Okay, let's move on to the next. In this one, we have got a rectangle in place, and if you look at the values, we have got 17 upon 40 will be equivalent to 11 upon x. Okay, let's move on to the next slide. So, okay, let, uh, okay, let me introduce you to the very interesting fact. If you look at any one of these A4, A5, or A3 sheets, are they proportional to each other? And if they are proportional, then what is the proportionality constant for these ones? For that, that is, if you put on x, okay, so let me, so this is what it is. So this the whole thing is 2y and x, and the other one will be x upon y. So if you look at A5, A5 has the dimension x and y, x upon y, this one. And if you go on to the A4 size, it will have two y's here, y and y, that will make y and x. So just solve this one. What you are going to get? You are going to get x should be equivalent to root of 2y. Okay, so let's move on to the next one. So here again, we have got few more exercises for you. So you can just build your confidence while doing these exercises. So let me have just one of them. Let me have this one. Let us do this fifth one. So if you look at the fifth one, how you will be doing this one. So in this one, we have 8, 5, x and 7. So if we look at the triangle, so this is P, Q, R, and this is A, B. So it will be ratios. So it will be PR upon PB equivalent to upon AB. So now you have to just put on the respective values and you can find out the value of x. It should be x plus 7 upon PB, that is 7 equivalent to 8 upon 5. So just solve this and you will get your answer. Okay, so this is going to be a very small teaching session as we just started off to find out how we can prove that, or how we can find out the two lengths or the length of the unknown which is missing there if the two triangles are similar. So thank you for joining me for this session.